Today's lesson will be on Pythagorean identities. So the first thing we're going to do is go over our homework. So in the first problem, I gave you guys cos x times tan x times the cosecant of x. What you guys have to do is you have to go in and kind of use those identities. I put them up on plus portals. Go ahead and print them out for yourself. That's going to be pretty much your key throughout this whole entire lesson. So cos x, we're going to keep it the same. Tan x, we can replace tan with sine x over cos x, and cosecant of x, we can replace it with 1 over sine of x. Now what we got to do is we got to multiply everything, or to make things easier first, I would go ahead and cross out our like terms. So we could cross out cos with cos and sine with sine, and we are left with 1. Your final answer for 1 is 1. Number 2, I gave you cos x times the cosecant of x over the cotan of x. So we go ahead and figure out which ones we could replace. Cos, I wouldn't replace with anything. Cosecant, or CSC of x, we can replace with 1 over sine of x. And cotan, we can replace with cos x over sine x. So we go ahead and multiply across. Cos x times 1 over sine x is going to give us cos x over sine of x, all divided by cos x over sine x. Remember, when we're dividing by a fraction, to get rid of it in the denominator, you got to multiply by the reciprocal. So cos x over sine x times sine x over cos x. Go ahead and cross out your like terms. So the 2 coses cancel out, 2 sines cancel out, and we're left with 1. So your final answer for this one is 1. In number 3, we got cotan x times secant of x, all divided by cosecant x. Now this one, since none of them are sine or cos, I'd replace every single one of these. So we replace cotan of x with cos x over sine x times secant of x is 1 over cos of x, and cosecant of x we can replace with 1 over sine x. To make things easier for yourself, the first thing I would do is cross out these 2 sines. When we do that, those 2 coses. When we do that, we get 1 over sine x, all divided by 1 over sine x. Remember, since this is a fraction in the denominator, to get rid of it, we got to multiply by the reciprocal. So we have 1 over sine x times sine x over 1. The 2 sines cancel out, and we're left with 1 over 1, which simplifies down to 1. In number 4, we have secant of x over tan x. So we can replace secant with 1 over cos, and we can replace tan with sine x over cos x. Remember, fraction in the denominator, to get rid of it, multiply by the reciprocal. So we're left with 1 over cos x from that original numerator times cos x over sine x. We could go ahead and cancel out the 2 coses. Now this, in the homework from the night beforehand, where a lot of you guys were messing up, was we have 1 on top and sine in the bottom. Some of you guys were just giving me your final answer as sine. It's 1 over sine. So 1 over sine can, if we look on our formula sheet, what is 1 over sine equal to? And that is cosecant of x, or CSC x. Now we're going to work with our Pythagorean identities. So the first thing I give you guys is all your reciprocal identities. These, what I'm going to explain now. So these work both ways. So you can have 1 over CSC is equal to sine x, or sine x is equal to 1 over CSC. Cos x is equal to 1 over secant x, or 1 over secant x is equal to cos x. Tan x is equal to 1 over cotan x, or 1 over cotan x is equal to tan x. Then over here we have cosecant of x is equal to 1 over sine of x, or 1 over sine of x is equal to cosecant of x. Secant of x is equal to 1 over cos x, or 1 over cos x is equal to secant of x. We can also have cotan x is equal to 1 over tan x, or 1 over tan x is equal to cotan x. These quotient identities, once again, they all pretty much stay the same. Tan x is equal to 1 over cotan x, or for the most part, you're going to be using tan x as sine over cos, and cotan x is equal to 1 over tan x, or cos over sine. And for the most part, when you have cotan, you're going to go ahead and use cos over sine. What's important to know, we're going to see it in a couple of minutes in the one example, is now these identities up here. You can square these. So you can have sine x, cos x, tan x, cosecant x squared, secant squared x, and cotan squared x. We could square these, but when we do the next one, when I show you guys the actual Pythagorean identities, you can't say those are just 1x. Those are always going to be squared. These ones can work both ways. They can be squared or they can be singular, as they are right here. We'll go over that in a second. On today's pet of the day, this is Ginger. Once again, this is our neighbor's dog. So Ginger came over and she was eating some vanilla bean ice cream. So if you guys send me an email with what Ginger was eating, I'll give you guys 1 point on your next quiz or test that we have. These are your Pythagorean identities. So the ones in bold, so this one over here, this one over here, and this one over here. These are your main three. On your formula sheet, I put that these are the parent identities, and the two listed underneath, those are going to be what we call as like your children identities. So I went ahead and rearranged them to different ways that you would see them on quizzes, tests, and homeworks. So for the first identity, you have sine squared x plus cos squared x is equal to 1. Another way you can rewrite it is sine squared x is equal to 1 minus cos squared x. How did I get this? I just subtracted cos squared x from both sides. Another way you'll see it as is cos squared x is equal to 1 minus sine squared x. How did I get that? I just subtracted sine squared x from both sides. The second identity we have is cosecant squared x is equal to cotan squared x plus 1. Two other ways you could see those written as is cotan squared x is equal to cosecant squared x minus 1. How did I get that? What did I do for this? I just subtracted 1 on both sides of the equation. And another way you could see it is 1 is equal to cosecant squared x minus cotan squared x. How did I get that? I just subtracted cotan squared x from both sides. And the last identity, tan squared x plus 1 is equal to secant squared x. So another way you'll see it as tan squared x is equal to secant squared x minus 1. How did I get that? Subtracted 1 on both sides. And the other way you'll see it is 1 is equal to secant squared x minus tan squared x. How did I get that? Subtracted tan squared x from both sides. Now we're actually going to go ahead and do some problems. So I want you guys to simplify tan squared x over secant squared x. First thing you guys should do is you can replace tan squared x with sine squared x over cos squared x. Remember when I told you these reciprocal identities we can square? That's what I mean by that. Square them. And secant squared x we can replace with 1 over cos squared x. So we go ahead and plug what we were going to replace tan with and what we're going to replace secant with into the fractions. So we have sine squared x over cos squared x in place of tan squared x, and in place of secant we're going to put 1 over cos squared x. Remember, because it's a fraction divided by a fraction, what we do to get rid of the fraction in the bottom is, you guys have been seeing it over here, is multiply by the reciprocal. When we do that, the coses cancel out, and we're left with sine squared x. Your final answer for this problem would be sine squared x. The next example, I give you tan squared x plus 1 times 1 minus cos squared x. Now you guys are probably looking at it and wanting to go ahead and FOIL. Don't FOIL just yet. You can replace, what can you replace tan squared x plus 1 with? You can replace it with secant squared x. Where did I get that? From these Pythagorean identities. Over here, we had tan squared x plus 1, we got is equal to secant squared x. 1 minus cos squared x we can replace with sine squared x. So we go ahead and do that. So it now, instead of tan squared x plus 1, it becomes secant squared x, and instead of 1 minus cos squared x, it becomes sine squared x. So we're multiplying these two. But to make things a little easier, we can replace secant squared x again. So secant squared x could become 1 over cos squared x times sine squared x. Go ahead and multiply, and we get sine squared x over cos squared x. What does that go ahead and equal to? We get tan squared x. That is your final answer. Let's try this one. 1 minus secant squared x. So 1 minus secant squared we can replace. So what we're going to be replacing, you might not see this 1 minus secant squared on those Pythagorean identities, but that's okay. If we see secant squared x, what can we replace that with? We can replace that with 1 plus tan squared x. So instead of secant squared x, I now go and plug in 1 plus tan squared x. And this 1 minus in front, we just kind of carry that down. Now, because it's a minus, we got to distribute that. So now we're left with 1 minus tan squared x. 1 minus 1, that gives us 0, so we don't have to rewrite that. And we're left with negative tan squared x. Now this is your final answer. Now let's try this one. Sine squared x plus cotan squared x times sine squared x. First thing, don't go ahead and simplify sine squared x. Just kind of keep it there. So sine squared x plus, we can replace cotan squared x. And that becomes cos squared x over sine squared x. And then we just bring down this sine squared x. Now we can go ahead and cross out like terms. We can't cross this sign with that sign because there's a plus sign in between, but we can cross out this sign with that sign. So we go ahead and do that. When we do that, we get 1. So we're left with sine squared x plus cos squared x. Now we can look at our Pythagorean identities sheet. We see if that's listed there. If it is, it is. So it is equal to 1. So pretty much all you guys are doing for this lesson is referring back to that sheet once again that's on Portals and looking to see what we can plug in for each other. So for this one, all we went ahead and did was, I didn't touch this one. I didn't fill in sine squared x is equal to anything. I replaced the cotan with cos squared over sine squared and just brought down the sine. Then we crossed out our like terms. Remember, we can't do these two because there's a plus sign between. Cross those out. We get sine squared x plus cos squared x. Look at your formula sheet. What is that equal to? And that's equal to what? As a reminder, your homework is on Plus Portals. When you finish it, make sure you guys submit it to me. I'm also going to be uploading on Portals some different ways for you guys to submit your homework assignments to me. So if we want to try that out, let's give that a try. I'll be sure to post that in portals. Have a great day, guys.